Hello, welcome to the Maths Matrix and part 4 in the ratio series. My name's Rebecca and in this video we're going to be looking at harder exam applications of ratio. You'll need paper and a pen and your general ratio work will need to be quite strong. If you're not very good at ratio yet, then don't watch this video. Instead, practice scaling up ratios and dividing in a given ratio. They're probably the most important principles that you need to know. If you can do those confidently already, then stick with this video and we'll look at how they're extended up to harder GCSE questions. Let's get started. If you continue with your notes and put a subtitle of harder exam style ratio questions. And then just put e.g. In a restaurant, starters, mains and desserts are sold in the ratio 5 to 7 to 3. 240 more mains are sold than desserts. How many dishes are sold in total? Okay, so in that question we were told that starters, mains and desserts are in the ratio 5 to 7 to 3 and that 240 more mains were sold than desserts. And we're being asked how many meals must have been sold altogether. The key to this question is remembering that ratio is all about parts. So ratio questions are all to do with how many parts you have. We're being told that 240 more mains than desserts are being sold. 7 parts main are being sold and 3 parts dessert are being sold. 7 take away 3 is 4. So that means that 4 parts more mains are sold than desserts. So the key to this question, the key to unlocking this question is to do a takeaway, because then we know that if 7 parts mains were sold and 3 parts desserts were sold, to give a difference of 4 parts, and that equates to 240 actual meals. What we then know is that 240 equals 4 parts. And if 240 equals 4 parts, then if we divide by 4, that'll tell us what 1 part is equal to, which would give us 60. So we know that 1 part must equal 60 meals or dishes. Now 5 parts were starters, so for the starters we have 5 parts, so 5 times 60, which is 300. For the mains we have 7 parts being sold, which is 7 times 60, which is 420. And for the desserts, we have 3 parts being sold, which is 3 times 60, which is 180. So 300 starters were sold, 420 mains were sold, and 180 desserts were sold. So altogether, the number of meals sold, if we add all those up, is 900. So the answer would be 900 meals were sold. Okay? So the question told us how many more of this thing than that thing. So we had to look at the ratio and do a takeaway to figure out how many parts that equated to. And when we know that this many meals equals that many parts, then we can divide down to find one part. And when we know what one part is, then we can scale up to find out how many actual starters, mains and desserts were sold. And then since the question here said how many meals altogether was that, we added them up to get 900. Okay? So there aren't really notes that you can make about this. There's not a set formula that I can give you like I did for dividing in a given ratio. Each question might be slightly different, but that's the principle of what's gone on. So if you've not copied all of that down yet, then just hit pause on your screen and copy down that working with whatever notes you need. If you want to put little arrows at any of it to tell you what's actually gone on, then do that. And when you've finished copying it down and annotating it, hit play and we'll do another question similar, okay? All right, let's do a similar question. So if you put e.g. in your notes again and then write, in a triangle, the sides are in the ratio 11 to 5 to 4. The difference between the long and short sides is 35 centimetres. What is the perimeter? All right, so in this question, we've got our three sides of a triangle. The long side is going to be the 11, the short side is going to be 4, and then I'll just put M for the middle side, the medium one or the one in the middle. So the difference we were told between the long and short side is 35 centimetres. Parts-wise, the long side is 11 parts and the short side is 4 parts. So again, the key to unlocking this question is to do 11 take away 4, which is 7 parts. So there's 7 actual parts worth of difference between the long and short sides, and that is worth 35 centimetres because the question says so. So we'd put 35 centimetres equals 7 parts. And that really is the question unlocked then, because from our 7 parts, we can divide by 7 to give 1 part, which means we have to divide that side by 7 as well to give us 5 centimetres. So 5 centimetres equals 1 part. And if 5 centimetres equals 1 part, then our long side must be 11 times 5, which is 55 centimetres, because the long side is 11 parts. The middle side, or the medium side, is worth 5 parts, so it's worth 5 lots of 5 centimetres, which is 25 centimetres. And then the short side is worth 4 parts, so 4 lots of 5 centimetres, which is 20 centimetres. So the long is 55, the middle is 25, and the short is 20 centimetres. And the question asked us, what's the perimeter of the triangle? Well, perimeter is all the sides added together. So if I add those up, I get 100 centimetres. So the perimeter of that triangle, adding those sides up, would be 100 centimetres. I've definitely seen questions like that on Edexcel's iGCSE and more recently on plain Edexcel as well. So it does come up, that style of question. The story will change, but in general, it's a takeaway to start you off, followed by that quantity equals that many parts. And from there, you can scale down to 1 part and scale back up to answer whatever it is that you're specifically being asked about. All right? We'll do a slightly different type of exam question now. So if you just put e.g. again, and then put The ratio of geese to ducks is 2 to 7. I'm going to write some of this down just to remind me what's going on. You don't write what I'm writing, you write the actual full sentences. So the ratio of geese to ducks is 2 to 7. The ratio of ducks to swans is 4 to 1. What is the smallest possible number of birds on the pond? Okay, so in this question, we're given two separate ratios. We're told the ratio of geese to ducks is 2 to 7, and the ratio of ducks to swans is 4 to 1. And we're being asked what's the smallest possible number of birds that can be on the pond. These kinds of questions are a sort of cross between lowest common multiple and common denominators of fractions. It's a kind of hybrid, really, of those two topics. What we first of all need is to bring these two separate ratios together as one three-way ratio. But the problem is, although they've both got a ducks component, in one of them the ducks part is 7 and in the other part the ducks is 4. So what we need to do is make ducks be a common number, almost like finding a common denominator in two separate fractions. So I'm going to scale each of these up to give me one common middle number. Well, 7 and 4 have a common multiple of 28. So if I use 28 to be my middle number representing ducks, to get from 7 to 28, I've multiplied by 4. So I need to times the geese by 4 as well, so that my ratio of geese to ducks actually stays balanced, actually stays in the same portions, just a scaled up version. So 2 times 4 is 8. So all I've done is effectively scaled up a ratio. I'm now going to scale up this ratio as well. So to get from there to there, I've times by 7. To get from 4 to 28, I've times by 7. And therefore I need to scale up my swans by a factor of 7 as well. So 1 times 7 gives me 7. And my ducks, 28, can go in the middle. So I've brought two fractions into one three-way fraction with my common thing, ducks, going in the middle, and a lowest common multiple going in the middle as well. That then tells me that there's 8 parts geese, 28 parts duck, and 7 parts swan. The smallest possible number of birds is generated by just adding those numbers together. So 8 plus 28 makes 36, and add 7 on makes 43. So the smallest number of birds is 43. It's not the only possible number of birds, because ducks, geese and swans being in the ratio 8, 28 and 7 means that I could times each of those by 2 to have 16 geese, 56 ducks and 14 swans, and they would still be in the same ratio, just a scaled up version of it. I could times each of them by 3 to give me 24 ducks and whatever 28 threes is, and 21 swans, and they'd still be in the ratio 8 to 28 to 7. But you can only have whole numbers of birds. You can't have half a swan on a pond or half a goose on a pond. And so the smallest number of birds that will satisfy that ratio there is when we have 8 geese, 28 ducks and 7 swans, which gives us a total of 43 birds overall. All right, so let's do another question like that. Again, I'm going to jot things down on here just to remind me in a second what's gone on. you write what I'm saying, not what I'm writing, okay? So put, e.g., in an ice cream shop, the ratio of strawberry ice creams to chocolate ice creams is 3:4. The ratio of strawberry ice creams to vanilla ice creams is 5:4. 60 chocolate ice creams are sold. How many strawberry and vanilla? Alright, so that's the same kind of scenario really as the ducks, geese and swans question that we've just done. Apart from now, strawberry is on the left in both cases. So what I'm going to do first of all is I want strawberry to end up in the middle because I need to bring these two separate ratios together as one big ratio. And since strawberry is the thing that they both have, then strawberry will be going in the middle. So I'll put chocolate there and vanilla there, which means strawberry and vanilla can stay that way round. But I'm just going to rewrite this one as chocolate to strawberry being 4:3. So whereas I had strawberry to chocolate was 3:4, I'm now just turning the whole thing backwards to put chocolate and strawberry 4:3 instead, so that strawberry is kind of in the middle. This one has 3 parts strawberry. That one has 5 parts strawberry. And I need to scale them up so that they have a number that agrees. So 3 and 5 both go into 15. So I can pick 15 as a common thing between the 3 and the 5. I don't know what you'd call it. It's not a common denominator, but a common side of fraction. To get from 3 to 15 in the chocolate-strawberry ratio, I've multiplied the 3 by 5. So to keep the balance of parts the same, I need to times the chocolate by 5 as well, which would give me 20 chocolate. With this one, to scale the strawberry from 5 to 15, I've multiplied by 3. So I also need to times vanilla by 3 to keep the parts of strawberry to vanilla in balance. So I've flicked that one round and I've scaled them both up and I've fused them together to give me one single 3-way ratio that says chocolate to strawberry to vanilla is 20 to 15 to 12. So that's the ratio of strawberry, chocolate and vanilla ice creams that were actually sold. The question then tells us that 60 chocolate ice creams were sold. So instead of 20 being sold, 60 are sold. And it says how many strawberry and vanilla. At that point, it's just a case then of scaling up this triple ratio. So to get from 20 to 60, we're multiplying by 3. So to keep all the parts balanced, I need to times the strawberry by 3 as well to give 45, and the vanilla by 3 as well to give 36, which means that to answer the question that was being posed, 45 strawberry ice cream are sold. So you'd put in your answer space in an exam 45 strawberry, and you'd put 12 vanilla, because that's the question that was actually being asked in words. All right, This kind of ratio question is quite new. I never saw anything like this until the new style GCSEs came in. So I think it's quite likely actually that you might get a question like this, particularly if you're on edXL. So if your ratio work is generally quite strong, and particularly if you're going for one of the higher levels, then this is definitely worth bearing in mind and practicing, because I think it's probably likely to come up. It could be on a non-calculator paper with nice easy numbers like I've just done here. It could be on a calculator paper with slightly harder numbers, but the principles don't change. It's just that if you needed a calculator to do some of the timesing or dividing, if the numbers were worse, then you'd use one. I'm going to pop some questions on screen now so that you can practice this type of question and the one that we did previously where we had to start off with a takeaway and say this many parts equals that quantity. There's a couple like that and some like this so that you can see a range of exam style questions. I'll put a second sheet up after that with the solutions so that you can mark them, check you've got them right. Thank you very much for watching. Please consider subscribing or liking this video, and I will see you next time.